The shocking fact hook. In 10 seconds, I'm going to show you how a Roman ruin directly predicted the design of the Burj Khalifa using only Google Earth. You have 3, 2, 1 to see how 2,000 years of structural engineering accelerated faster than you ever imagined. Let's dive into the timeline right now. The interactive challenge hook. Can you spot the engineering flaw in the Great Pyramids using just your browser? We have 5 seconds to analyze the geometry before we jump to 2026's skyscrapers. 5, 4, 3, 2, 1. Prepare to see iconic landmarks in 3D like never before, exposing the secrets of architectural evolution. The visual curiosity hook. Look closely at this 3D render of the Eiffel Tower. It's actually a clue to the future of construction. 5, 4, 3, 2, 1. We are taking a flying tour from Rome to Dubai to trace how humanity redesigned the skyline. If you don't watch this now, you'll miss the structural revolution. We begin above Rome, zooming over cobblestones and ruins, watching geometry written in stone centuries before steel changed the skyline. This is not tourism, it's forensic engineering. Each ruin stores a design lesson that echoes into glass and concrete today. From Rome's foundations, we will fly across continents, tracing lines from ancient arches to the Burj's needle on the Dubai horizon. Rome's triumphal arches distribute compression with elegant curves, a lesson in transferring loads that modern towers still rely on. Look at vaults and buttresses. Roman engineers spanned open space long before today's alloys or cranes existed. Analyze their foundations, layered materials, drainage channels, and calculated weight spread. Ancient answers to modern settlement problems. Split screen reveals Roman arch geometry beside a skyscraper core. The same forces, different materials, similar structural logic. In the 3D flyover, we isolate curvature that would later reappear as strategic tapering and stage setbacks. These are seeds of vertical thinking, stacked modules, controlled mass, and intentional voids to reduce structural stress. Next, the Great Pyramids. Monumentality masks a technical conversation with the future of load and settlement control. Can you spot the flaw? Geometry reveals strain points, settlement lines, and where weight had to be channeled to the base. We pause to study the slope and core, micro-failures that informed later structures and the evolution of corrective techniques. Then the Eiffel Tower, a lattice answer to height, open trusses, minimal weight, and an obsession with wind behavior. The Eiffel's silhouette teaches tapering and porosity, ideas reused in spires to cut wind vortexes and lighten mass high above ground. Overlay the pyramid, Eiffel, and towers. Patterns emerge: taper, stiffness distribution, and controlled mass movement toward foundations. From steel to composite cores, skyscrapers learned to stack, flex, and breathe. Engineering became a choreography with nature. Watch staged setbacks evolve into aerodynamic shaping. Each cut and curve is an answer to wind, weight, and function. The Eiffel hinted at lightness. The pyramid taught mass control. Together, they preface a modern era where computation enables audacity. Split screen shows early facades beside glass skins and outrigger systems, a visible lineage from simple forms to engineered complexity. Fast cuts highlight load paths: foundation, core, outriggers, and tuned mass dampers. Each step traces back to ancient intuition. Now we accelerate toward the 21st century, where materials, computation, and ambition collide into iconic vertical forms. Approaching Dubai, the desert folds into a man-made vertical oasis, the Burj rising like a scaled translation of ancient strategies. The Burj's stepped, tapering form reduces wind forces. Its buttressed core mirrors the logic of Roman cores and pyramid massing. Split-screen overlay places a Roman ruin, an Eiffel segment, a pyramid slope, and the Burj elevation. See the lineage in structural vocabulary. Annotations point to load transfer, pivot nodes, and aerodynamic shaping. Ancient solutions reframed by steel, concrete, and computation. Final cinematic flyover takes us from Rome to Dubai in seconds, color-graded in deep blues and warm golds, revealing a continuous design thread. Takeaway: engineering is cumulative. The Burj is not a leap out of nowhere. It stands on 2 millennia of solved problems.